when multiplying a binomial times a trinomial, something that you can't use FOIL because one of the items has more than one term. For example, look at D on this problem. You can draw a box that has the same number of rows and columns as the number of terms that you see in the problem. Since the first polynomial is m plus 3, that's 2 terms, and if we have this set up with 2 rows, you can put m plus 3 outside the rows of the box. Since the trinomial has 3 terms, we're going to have to set it up with 3 columns. So you'd put m squared over the first column minus 2m over the second plus 1. Now all you have to do is multiply each term in the row by each term in the column, and the answer will go in the box where they intersect. For example, m times m squared gives you m to the third. Remember, if you're multiplying, add the exponents. And even though we don't see 1 as the exponent on m, we understand that that's m to the first. If you move across this row, the next one would be m times negative 2m. That would be minus 2m squared. And then finally we have m times positive 1. That's a positive 1m. The 1 is optional to write down. Normally we don't write it down. To do the bottom row, now we're going to multiply everything by 3. So 3 times m squared is 3m squared. 3 times negative 2m would be negative 6m. And 3 times positive 1 is positive 3. Now we look to see if we have any like terms, and if we do, we combine them. Normally, like terms will show up on the diagonal. I have a couple of terms that are m squared, and I have a couple of terms that are m to the first. So if I write this now in descending order, my term with the largest exponent is in the top left. That's m to the third. If I add 3m squared and negative 2m squared, 3 plus negative 2 gives me a positive 1m squared. And then negative 6m plus 1 more m would be minus 5m. And then in the bottom right corner, we still have plus 3. This would be how you would multiply a binomial times a trinomial using the box or the rectangle method.